everybody, thanks for joining us today and welcome to LogicMonitor's 201 Advanced Webinar Series. My name is Sarah Terry and I'm on the product team here at LogicMonitor. I also have Mike Arisic, one of our Senior Solutions Engineers, and Victoria Odine, one of our Technical Trainers here with me. This is the third webinar in our Advanced Webinar Series. In today's webinar, we'll show you how to monitor multiple layers of the infrastructure responsible for keeping a website up and running. We're going to use an example website that we put together using a fairly simple AWS setup. But keep in mind that most of everything we're talking about can be applied to multiple other scenarios, and even just website monitoring in general. So let's take a quick poll to see how many people today are actually using AWS for their websites.
Good.
So we'll give you about a minute or so to respond to this poll. And I'll note that today we're going to cover best practices for monitoring a website. So we're going to talk about what kinds of information you can get about your website and the components that go into preserving its uptime, and how you can set up really comprehensive monitoring for this information in LogicMonitor. Now, ideally, this comprehensive monitoring can help you troubleshoot and resolve issues as quickly as possible, or hopefully you have things configured so that LogicMonitor alerts you in time to prevent the issues from occurring in the first place. And then we're also going to cover how you can use AWS with LogicMonitor to your advantage, and how this allows you to see all of your monitored infrastructure from one pane of glass. So I'm going to close the poll now. And just so that you all know, we're going to be recording this session, so you will all be emailed a link to the recording following the webinar. So in today's webinar, we're going to cover how to monitor your website using LogicMonitor, how to monitor your website from inside your network, how to monitor your website from outside your network, how LogicMonitor's AWS beta monitoring functionality works, and how it applies to monitoring website components. And then we'll have a demonstration on how to set up this comprehensive monitoring in LogicMonitor for your hosted website. And then we're going to have a question and answer session at the end for any questions you guys may have. So as questions come up during the webinar, just enter them into the GoToWebinar interface on your screen and we'll answer them. So I'm sure that you're all familiar with the fact that the majority of LogicMonitor's monitoring originates from a collector, which of course is sitting on a server inside your network, behind your firewall, or maybe it's sitting on a virtual AWS server, like we're going to show you in our example today. Either way, this means that the collector has access to the behind-the-scenes infrastructure components that your website is running on. We also know that even if all of the equipment on our site is functioning perfectly, there are still multiple external factors that could potentially prevent outside users from being able to access our website. So if we want to monitor the full picture, we also need to have checks that come from outside our network. So the last step will be setting up periodic checks from external locations to mimic the experience of a user accessing our site. And there will be some overlap in the information we're monitoring, but there are a number of different combinations of things can go wrong. And when something does go wrong, we see inconsistencies in the same information monitored from different perspectives, then we have a piece of information that we can help use to troubleshoot the problem faster. So remember that LogicMonitor has a variety of collection methods, which is how we get data for various types of devices and applications. And we actually have a web page collection method that allows us to query data from any system using HTTP or HTTPS. And LogicMonitor has a default HTTP page data source that checks for load time and availability of a web page. And we're going to show you how to customize this data source to look for specific content on a web page to ensure that it's the right web page that's available. And this is similar to how our services monitoring works, but the web page monitoring originates from the collector in your environment. And then the LogicMonitor Apache data source also uses the web page collection method. And how that works is we're actually accessing the server status page using HTTP. And really, it's pretty useful to monitor Apache because this is the application serving the web pages for your site. And if the web pages do stop working, then the monitored data will let you know whether it's an Apache problem or another problem, for example, a problem with the config file. And all that's required to enable the Apache monitoring is to make sure that the server status page is accessible. And we're going to show you guys how to do that in a demonstration in just a little bit. And the way that LogicMonitor does external monitoring of websites is from the Services tab, which lets you set up periodic checks from any combination of 5 possible LogicMonitor site monitor locations: San Francisco, Los Angeles, Washington, D.C., Singapore, and Dublin. And you can configure services so that your website is periodically tested from outside your network and specifically from one or more of these site monitor locations to ensure that it's available as often as possible. So getting into the demo side of this webinar, it's becoming pretty common to use AWS for on-demand resources that are reliable and disposable. So we decided that AWS would be a great way for us to put together a simple scenario to show how to set up comprehensive website monitoring in LogicMonitor. We wanted to limit the number of components we're dealing with in this scenario to keep things simple and concise. But keep in mind that once you understand the basics of what we're doing here and how we're doing it, you'll be able to apply it to multiple other scenarios with more complex architecture. So to give you a visual of the scenario we're working with today, we set up a basic demo website that we're going to run using Apache on 2 AWS EC2 servers that are sitting behind an AWS Elastic Load Balancer. So thinking through the full picture, we have our end user that's probably going to access our site by its CNAME, which points to the public DNS of the Elastic Load Balancer. The ELB then routes the request to one of our 2 EC2 servers. The EC2 servers both have Apache installed and running, and they both have our website's HTML config file on them. And then we installed a LogicMonitor collector on one of the servers. And so another reason we chose to use AWS for a demonstration on this webinar was we wanted to show off LogicMonitor's new AWS monitoring functionality. So LogicMonitor has AWS monitoring, and it is still in beta right now. But basically, it uses the AWS SDK to get CloudWatch metrics, and then also to compute some metrics that CloudWatch doesn't provide, and allows you to monitor your AWS cloud resources alongside your existing monitored architecture in LogicMonitor. And so we're going to use the AWS beta monitoring functionality today to monitor our Elastic Load Balancer in our demonstration. And really, we don't need to monitor our ELB for being up or down because it's a service, so that should be pretty reliable. But it would be nice to look for errors and to get an overall idea of capacity, or the number of people hitting our demo webpage, because remember, all of this traffic is going through our load balancer. So we're going to show how to set up this monitoring in addition to the website monitoring we'll be setting up. So if you recall from our earlier slide, we've spun up 2 EC2 servers with basic Linux distributions and 1 Elastic Load Balancer in our AWS account, and we put the 2 servers behind the load balancer. We installed Apache on both servers and created a really simple, goofy website for today's demonstration. And then we also created a DNS entry for our website and gave it a CNAME. So we're going to demonstrate how to use LogicMonitor to monitor this website from inside our network and outside our network. And then we're also going to go over how to monitor Apache with LogicMonitor's Apache data sources. So let's first try and access the website with its CNAME to make sure that it's working. And as I said, this is a ridiculously simple website that we put together for today's webinar. It is obviously not the focal point of the webinar, but it is sufficient for today's demonstration. And so before this demonstration, we went ahead and installed a collector on one of our servers. So now we can add both of our EC2 servers as LogicMonitor devices. But actually, before we add these servers as devices in our LogicMonitor account, we need to make sure that the collector, which we installed on one of the servers, can monitor both servers. So we're going to show you the security group rules we have set up that enables this communication. Now keep in mind that if this were a true production environment, you would probably want your load balancer to be in a separate security group. But for simplicity's sake, we're just going to have everything in our one security group. So here are rules. We have a rule for UDP, which is for SNMP collection, a rule for ICMP, which is for ping, and then our basic HTTP and SSH rules. And to reiterate, what we have in the source field for the UDP and ICMP rules is the ID of our security group. And obviously we left the HTTP rule unrestricted because we want everyone to be able to access the site. And then we added a custom IP range for SSH rule so that we could only SSH into our servers from our internal network. So let's go ahead and add our servers to our LogicMonitor account. We're going to add them using the wizard. And then we'll use the private DNS names because that's what's going to give us the detailed monitoring information from inside of our network. And then we're going to do this for both servers. And we already did set the community strings for these devices, which speeds things up when you're in the process of adding a device to LogicMonitor. All right, now we won't see Apache data sources right off the bat, because in order for Active Discovery to detect that a web server is using Apache, the collector must be able to pull the server status page. And by default, Apache does not allow access to this page. So we need to edit the Apache configuration file to allow the collector to pull the server status page. And we have a pretty comprehensive set of instructions on how to do this in our help documentation, but we're just going to go ahead and show you how to do this right now. So we need to edit the Apache configuration file. And we're actually just going to copy and paste a section from our help docs and insert it at the end here. And then obviously we do need to replace the IP address here with the IP address of our collector. And then we need to restart the Apache service. Great, and now we should be able to schedule Active Discovery and see the Apache data sources applied to our server. We'll refresh the page here, and there they are. And so that is how you set up monitoring for Apache. So the next step is to set up a data source to monitor a web page from inside our internal network. Now specifically, the web page will be monitored from our collector we installed on our server. And as I previously mentioned, monitoring internally is really useful for pinpointing a problem when something goes wrong. So the data source used for this monitoring is the HTTP page data source. But we're going to do a little bit of customization to fit our particular use case here. So we're going to clone this data source, and we'll give it a name. And then we want to apply this data source to both of our AWS EC2 instances. And as a best practice, we're just going to hard code these hosts into the applies to field at first until the data source is working and polished, and then we can come up with something a little bit more general so that we can apply the data source to a group, for example, that contains all of the components for our website. We'll click Save. And then in the request field, we're going to change the HTTP version to 1.1 here. And then we're going to add a line for the host. And the value for this host needs to specify what you want to test, such as your website alias. So if you have one server with two websites and you want to check just one of those websites, you can hard code that in here. But since we instead have two servers with one website, we're going to leave the host wildcarded so that it applies to both servers. And in this particular case, we don't want to hard code in the host name because we have two host names and we don't want to have to create two data sources. And so as is, this data source will monitor the status of our website pages, where each page of our website will be an instance of this data source. So we can navigate to the Devices tab. We'll pick one of our AWS servers, and then we'll add a monitored instance for this data source. And so the data source is the one we just created. And then we're going to give this instance a name. And the wildcard for our instance is going to be everything after the host name, which in this case is just our CNAME. So for our main page, our wildcard value will be just a /. And then we can add another instance for our second page. And here's our second page. So we'll add another monitored instance. And we'll save that. So there we go. We have both of our website pages added. So now our data source should be monitoring the status of the responses of both pages of our website. And just to be thorough and for demonstration purposes, we can add an instance with a wildcard that points to a page that doesn't exist to ensure that this check is working correctly. So we'll do that. And we'll just add a wildcard of /false. But really, it is not sufficient to just get a response from a page because we need to make sure that the correct content is there and that it's the right web page. So let's go back to the data source definition, and we can add a data point that checks for something specific content-wise. But first we have to decide what to look for on our web pages that would confirm that this is the content we're looking for. So we see that both of the pages have the words kittens with a capital K and then LogicMonitor Incorporated 2015. So what we can do is add a data point that checks for this content. So we'll give it a name. And then we want to look for the presence of a string. And we'll just give it a regex here to look for kittens dot plus LogicMonitor Incorporated 2015. Great. And then we will set the alert threshold to not equal 1. And then we're going to add another 1. And remember that our thresholds have 3 severity levels, so we want to bypass the warning and go straight to an error here. And so this syntax specifies that if the regex match does not return a 1, an error alert will be generated. We can customize the alert message with tokens to say something that indicates that the content is not present on the web page. And then we'll save the data point. But before we save this data source, we're going to show you how to make the process of adding instances more automated. So in the real world, you may have 50 servers instead of 2, and manually adding instances for each of these servers would be tedious. So we can actually set up Active Discovery to automatically discover the instances for each of these servers. So the method we're going to show you is for when you want to check the exact same pages on all of your servers, but you can customize this so that it works for multiple other scenarios. So in our data source definition, we'll enable Active Discovery and set the Active Discovery method to script. And then we're going to choose Embedded Groovy Script. And remember that the way LogicMonitor interprets script output for script Active Discovery is wildcard ## alias. So we want our script to print the wildcard value ##, and then the alias value for each of our pages. So we're going to do print ln, and then space, quotation mark, / ##, page 1, end quotation mark, and then we'll do another line, print line, / more kittens, ##, page 2. And then actually, let's give these slightly more unique names because the manually added instances also have the same names. And that's all there is to it. We don't need any filters here, so we can just save this. So we should start getting data now, but we'll wait a few minutes and we can come back to look at this in a little bit. But that's how you monitor a web page internally from your collector. So now we've monitored our servers for all health and performance information. We're monitoring Apache, and we set a data source to monitor our website. So we've got the internal point of view covered. So the next thing to do is to set up the external site monitor checks, which, if you remember from before, are going to check your website's availability from outside your network. And this is really simple. We can navigate to the Services tab, and we'll add a web service to look for content on our website. And like I mentioned earlier, this ensures that a web page is accessible from the outside, which is important because if you have a website that isn't accessible, then it isn't a very useful website. So we're actually going to add two web services checks, one which accesses our site using the A record, and one which accesses the site using the CNAME we set up. And this way, we'll be able to troubleshoot better when something goes wrong. Obviously, if the A record, which is the public DNS of our load balancer, is unreachable, then the CNAME will also be unreachable. But if the CNAME is unreachable, then there may be a problem with the DNS entry. So for our new web service, we're going to add our CNAME for our load balancer as the URL to check. And then we can give this service a name and a description. And then for this service, we're going to leave all of the site monitor locations selected, but you don't have to check your website from every location. And we want to check for some content on our website. So we'll look for the plain text string kittens with a capital K that must be present in the page returned by our CNAME. And then we'll save this service. And then we'll add a second service using the A record or the public DNS name of our load balancer. And then we'll give it a name and a description. And then we're also going to check for the same content for this service. So the plain text string kittens must be present in the page returned. And we'll save this service. And then just to be extra thorough and to demonstrate how this works, we're going to set up a multi-step web service check. Now, typically, you would use the multi-step option for monitoring websites which require multiple steps or other complex interactions, but we're just going to go through how to set it up to check different sections of our website. So let's select Add Multi-Step Web Service, and the URL to check will be the CNAME for the main page of our website. And then we can give this service a name and a description quickly. And we're going to leave all the site monitor locations selected, but again, you can choose to have your website monitored from any one or more of these locations. And we will just leave the alert settings as they are for right now, and then we'll add a step. And the step URL to check will be everything after the main CNAME entered above. So in this case, /morekittens.html. And then we don't have anything complex, so we won't bother with any of the rest of this stuff, but we do want to look for a string in the response, where the response is the page returned by the URL we specified. So let's look for the string kittens with a capital K, and then we'll save this step, and we'll save the service. And that's how you set up monitoring from outside your network. And then the one last thing we wanted to show you guys is our new AWS beta functionality. And we can actually add our AWS account to LogicMonitor and have it discover our Amazon instances and monitor them. And LogicMonitor will monitor each instance using data reported by the CloudWatch API. And we do compute some information that's not reported in the CloudWatch metrics. So there is an advantage. But this really allows you to see all of your monitored devices in one pane of glass. So we're already monitoring our EC2 instances, but it would be really useful to monitor our ELB, and we can do that. So we have an ELB data source that should automatically apply to our load balancer once it's discovered. So let me show you guys how to configure that really quickly. And this is not available in all of your accounts because it is in beta, and it's still at the point where it's being enabled per account. So on the Devices tab, we've selected Add an AWS account, we've given it a name, and then we need our AWS keys so that LogicMonitor can get the data reported by the CloudWatch API. And these keys can be associated with just a read-only account. That's all the access we need. And then we need to tell it which AWS instances to discover. And so we're going to select ELB. And then we have our ELB in US West 2, but We could select all, it doesn't really matter. So let's test the connection and make sure it works. Success. Okay, and so we can save this and we should see an ELB group automatically created with our one load balancer as a device in this group. You might need to refresh the page and give it a minute. There it is. And so we'll give this some time to collect data, and then we'll come back and look at it in a few moments. Okay, so I want to review what we did in the demo. So we set up basic website checks on the CNAME and the A record from the Services tab in LogicMonitor to basically mimic the experience of an end user and make sure the website is publicly available. If the website is not reachable by either means, then LogicMonitor will send out an alert that there's a problem. We also set up monitoring for our AWS EC2 servers themselves by adding them as hosts to LogicMonitor using the private DNS. But we also set up monitoring for Apache running on each server, since without that, our website definitely won't work. We additionally set up monitoring for our website itself on each of our 2 servers using a customized HTTP data source to make sure the correct content is loading. And lastly, we set up monitoring for our Elastic Load Balancer using LogicMonitor's AWS beta monitoring functionality. All in all, this approach gives us several layers of redundancy and also means that in case of a problem, we'll be able to pinpoint the issue much faster. We also put together an overview dashboard to show the different monitoring components we set up in the demo and to show you the data we got. And you can see we have data for Apache requests, Apache response times, Apache servers aggregate data, Elastic Load Balancer, errors and latency, the response codes and spillover requests for our Elastic Load Balancer, and the requests per second. And for the Apache monitoring, we actually created custom graphs so that the Apache metrics for both servers would show up on the same graphs. And then we also have our Site Monitor widget, which is showing the status of the Site Monitor checks and the alerts for our content data point of our HTTP custom data source. And then I previously mentioned that we have some overlap in the data we're monitoring for our website, but I want to reiterate that this redundancy can give us some insight into what components aren't working properly when something goes wrong, especially when we see inconsistencies between data for the same component monitored from different perspectives. And then I also wanted to mention another cool use case that's come up in the past regarding monitoring a web page with an HTTP data source. So if you recall, in our demo scenario, our host name was variable because we wanted to check the same website but on 2 hosts. And the site name and the host name were the same because we were only running that one website. But in other scenarios, there may be different variables. For example, if you have a website that exists on multiple hosts and runs on multiple ports, then the port would also be a variable. And what you do in this scenario is have a port active discovery, and the port would be the wild value. But in this case, we knew that our website always used one of a range of ports, so we used a port discovery to find out which devices were running the site, and then automatically applied the data source to those devices. And the way the port active discovery works is that it checks all the devices that meet the applies to criteria for all the ports on the port number list, which in this case is 3 specific ports. And if the devices respond on one of the ports, then that port is added as an instance for the data source for that device. The HTTP request doesn't actually change in this case, but the wild value token needs to be added to the port field of the request, as you can see here on the screen. And so that concludes the content for today's webinar, and so I'm going to hand it over to Mike for a question and answer session. I see that we have plenty of questions here to be answered.
Okay, so it looks like one of the first questions we got is when you are not using AWS to host your website, how would that make things different? For instance, if you have an in-house hosted website.
As Sarah said, we used AWS as an example just because it was easy to set up. If you obviously you're going to have your own infrastructure, you might have hardware load balancers or some other software load balancer in place, and obviously, in a non-virtual environment, you would probably have networking hardware, and you would, and in a more sort of realistic application, you might also have other tiers, storage tiers and database tier and that sort of thing. So this was just a simple example that we used to illustrate the value of monitoring the different tiers. But you can of course apply this to your environment.
Okay, one of our next questions is about redirected websites. Can LogicMonitor handle monitoring redirected websites?
Absolutely. So both the data sources, the custom data sources that we built, and the external services checks can be configured to both follow or not follow redirects. And they can also be set to detect the response codes from redirects. So if redirects are an important part of your application, you would construct sets of tests to actually look for those redirects. And so you would probably have one check that went and looked for the redirect and didn't follow it, and then you'd have a second check that followed it to the eventual content, probably in both cases, both monitoring internally and externally.
Okay, cool. One of the next questions is about the negative test that we did when we added the false value to the instance list. What was the point of using that negative test, and what were we looking for?
So you always want to have a negative test to make sure that your tests are actually working properly. So in this case, we created a page. I think it was a page that just wasn't there, to make sure that the error code came through, and that we knew that the checks were in fact working and that they were doing what they expect.
But yeah, that would be something that you would obviously want to get rid of once you would confirm that, since you don't want to be getting constant alerts for the not present page. What about tokens? Can you use the token in other places, for instance, in a content data point?
Yes, so we looked for a particular bit of content using our regex that we wrote that used pieces of content that we knew were going to be on all the pages that particular data source was looking for. If you wanted to be more granular, either by host or perhaps even by instance, there are more tokens. There are host tokens that you can use, where you can assign custom host tokens, and then the data source has the wild value, the wild alias, and actually a description, and you could actually incorporate a value from that into the regex that is used to test the content. We wanted to keep it simple. Sometimes you have to make a decision whether you want to make more data sources or make one data source that is very flexible. And in this case, because we knew there was going to be content on all the pages we were checking, it was going to be the same. It was easier to do it that way. But if there was some variable, you can allow for that as well.
Okay, we have a question about whether LogicMonitor can handle authentications if the website requires some kind of login credentials.
So there are a couple of, well, it depends on how that works. Basic authentication is handled right out of the box, and NTLM, there are things built into the local website check. The external, I don't know if basic is in there. Actually, I think basic is, but I don't know if NTLM is. There are, now if you want to get more in terms of maintaining a session, if you need to do posts and gets, at that point, the basic website checker, the website data source, you need to replace that with a script, and there is a multi-step facility built into the external services check. So we can do it, it's just more work.
Okay, if you guys have any other questions, feel free to type those in as well.